NENOMATICA, where mathematics meets YouTube excellence. Welcome to our mathematics tutorial. Today we'll learn about simplifying expressions with exponents and radicals. We'll use important exponent rules and properties to solve these problems step by step. Let's look at our first example. We need to simplify 16 to the power of 7 times 125 squared divided by 25 cubed times 32 to the fourth power. First, let's express all numbers in terms of their prime factors. 16 is 2 to the fourth power, and 125 is 5 cubed. Now, let's continue with the denominator. 25 equals 5 squared, and 32 equals 2 to the fifth power. Now, we'll apply the power rule. When we have a power raised to another power, we multiply the exponents. Let's apply this rule to each term. Let's compute these exponents. In the numerator, 4 times 7 equals 28, and 3 times 2 equals 6. In the denominator, 2 times 3 equals 6, and 5 times 4 equals 20. Now, we can rearrange and combine like terms. Let's group the terms with the same bases together. When we divide powers with the same base, we subtract the exponents. Let's apply this rule to simplify our expression. Remember that any number raised to the power of 0 equals 1. So 5 to the power of 0 equals 1. And 2 to the power of 8 equals 256. Let's move to our second example. Here we need to simplify negative a to the power of 4 times negative a to the power of k times negative a to the power of 3k times negative a to the power of k minus 1. To solve this problem, we'll use the product of powers rule. When multiplying powers with the same base, we add the exponents. Now, we add all the exponents to simplify. So we have negative a to the power of 4 plus k plus 3k plus 1 plus k minus 1. Let's combine like terms in the exponent. We have 4 plus 1, which is 5, and k plus 3k plus k minus 1, which is 5k minus 1. Simplifying further, 5 plus negative 1 is 4, so we get negative a to the power of 5k plus 4. Let's move on to our final example. This time, we need to evaluate the expression. The square root of 3 raised to the power of square root of 3, all raised to the power of square root of 12. For this problem, we need to remember that a radical can be written as a fractional exponent. The square root of a number is equivalent to raising that number to the power of 1/2. Next, we apply the power rule as we did before. When a power is raised to another power, we multiply the exponents. Let's simplify the expression in the exponent. The square root of 12 is equal to the square root of 3 times 4, which is the square root of 3 times 2. The square root of 4 is 2, and the square root of 3 times the square root of 3 equals 3. So our exponent becomes 1/2 times 3 times 2, which is 3. Therefore, our final answer is 3 cubed, which equals 27. Let's start with our first example. If 5 to the power of it equals 10, find the value of 5 to the power of a plus 1. To solve this problem, we'll use the well-known property of exponents that says 5 to the power of a plus 1 can be expressed as 5 to the power of a multiplied by 5 to the power of 1. Now, we know from the problem statement that 5 to the power of it equals 10. So we'll substitute this value into our equation. Next, we can simplify this expression. 5 to the power of 1 is just 5. Finally, we multiply 10 by 5 to get our answer. So, if 5 to the power of it equals 10, then 5 to the power of a plus 1 equals 50. Let's move to our second example. If 5 to the power of it equals 10, find the value of 5 to the power of a minus 1. For this problem, we'll use another property of exponents. 5 to the power of a minus 1 can be expressed as 5 to the power of a divided by 5 to the power of 1. Again, we know from the problem statement that 5 to the power of it equals 10. So we'll substitute this value. Next, we simplify this expression. 5 to the power of 1 is just 5. Finally, we divide 10 by 5 to get our answer. If 5 raised to the power of a equals 10, what is 125 raised to the power of a? We'll start by recognizing that 125 can be written as 5 cubed. This allows us to use the power of a power property. Now, we can apply the power of a power rule which tells us that when we have a power raised to another power, we multiply the exponents. So 5 cubed raised to the power of equals 5 raised to 3 times a. So we've simplified 125 raised to the power of a to 5 raised to 3a. Now, let's use the given information to find the value. We know that 5 raised to the power of equals 10. So we can substitute this value. Finally, we calculate 10 cubed, which is 1,000. So 125 raised to the power of equals 1,000. Let's move on to our second example. If 5 raised to the power of equals 10, what is 25 raised to the power of a minus 1? First, let's rewrite 25 as 5 squared. Now we can apply the power of a power rule to simplify. This gives us 5 raised to 2 times a minus 1. Let's expand the exponent using the distributive property. 2 times a minus 1 equals 2 a minus 2. We can rewrite this as 5 raised to 2 divided by 5 squared using the negative exponent rule. Now, we can use the fact that 5 raised to the power of equals 10, which means that 5 raised to 2 equals 10 squared. Let's calculate 10 squared over 25. 10 squared is 100, and 100 divided by 25 equals 4. So 25 raised to the power of a minus 1 equals 4. We're given that a equals 8 raised to the power of 3 squared. We need to find a divided by 2, a squared, and a divided by 4. Let's start by simplifying the value of a. We have a equals 8 raised to the power of 3 squared. The exponent 3 squared equals 9, so we have a equals 8 to the power of 9. Now, let's calculate the value of a divided by 2. We have a divided by 2 equals 8 to the power of 9 divided by 2. This is equivalent to 8 to the power of 9 times 2 to the power of negative 1. Remember that 8 equals 2 cubed. So we have 2 cubed to the power of 9 times 2 to the power of negative 1. Using the power of a power rule, we get 2 to the power of 27 times 2 to the power of negative 1. Finally, using the product of powers rule, we add the exponents to get 2 to the power of 26. Next, let's find a squared. A squared equals 8 to the power of 9 squared. Using the power of a power rule, we multiply the exponents. 9 times 2 equals 18. So a squared equals 8 to the power of 18. Finally, let's calculate a divided by 4. A divided by 4 equals 8 to the power of 9 divided by 4. We can rewrite this as 8 to the power of 9 times 4 to the power of negative 1. Since 4 equals 2 squared, we have 8 to the power of 9 times 2 to the power of negative 2. Rewriting 8 as 2 cubed, we get 2 cubed to the power of 9 times 2 to the power of negative 2. Using the power of a power rule, we have 2 to the power of 27 times 2 to the power of negative 2. Finally, using the product of powers rule, we add the exponents to get 2 to the power of 25. Let's summarize our answers. We found that a divided by 2 equals 2 to the power of 26, a squared equals 8 to the power of 18, and a divided by 4 equals 2 to the power of 25. Finding the value of one exponential expression when we know the value of another related expression. Let's start with our first example. If 2 to the power of x equals 10, then what does 16 to the power of x minus 1 equal? And for our second example, if 2 to the power of x equals 10, then what does 0.125 to the power of 1 minus x equal? Let's solve these step by step to understand the relationship between these expressions. Let's focus on our first problem. We know that 2 raised to the power of x equals 10, and we want to find the value of 16 to the power of x minus 1. Our approach will be to rewrite the target expression in terms of powers of 2, then substitute what we know about 2 to the power of x. Let's get started by working through this systematically. Let's start solving our first problem. Step 1. We'll rewrite 16 as a power of 2. Since 16 equals 2 to the 4th power, we can rewrite 16 to the power of x minus 1 as 2 to the 4th power, all raised to the power of x minus 1. Step 2. Using the laws of exponents, specifically the rule that says the power of a power means we multiply the exponents, we can simplify the expression to 2 raised to the power of 4 times the quantity x minus 1. Step 3. Let's distribute the factor of 4. This gives us 2 to the power of 4x minus 4. Step 4. Using another exponent rule, we can split this into a product. We get 2 to the power of 4x times 2 to the power of negative 4. Step 5. Now, let's recognize that 2 to the power of 4x can be rewritten. Since 2 to the power of x equals 10, 2 to the power of 4x equals 10 to the fourth power. Step 6. Now we have 10 to the fourth power divided by 2 to the fourth power. We can simplify this to the fraction 10 over 2, all raised to the fourth power. Step 7. Simplifying further, 10 divided by 2 is 5. So our answer is 5 to the fourth power, or 625. Now that we've solved our first problem, let's move on to the second one. Recall that we know 2 to the power of x equals 10, and we want to find the value of 0.125 to the power of 1 minus x. We'll use a similar approach. Rewrite the expression in terms of powers of 2, then substitute what we know about 2 to the power of x. Let's solve the second problem step by step. Step 1. First, we need to understand what 0.125 is. We can write it as the fraction 1/8, or 1 over 8. Step 2. We know that 8 equals 2 cubed. So 1/8 equals 1 divided by 2 cubed, which is 2 to the negative third power. Step 3. Now we can rewrite our expression. 0.125 to the power of 1 minus x equals 2 to the negative third power, all raised to the power of 1 minus x. Step 4. Using the power of a power rule again, we get 2 to the power of negative 3 times the quantity 1 minus x. Step 5. Let's distribute the negative 3. This gives us 2 to the power of negative 3 plus 3x. Step 6. Rearranging, we get 2 to the power of 3x minus 3. Step 7. Using the product rule for exponents, we can split this into 2 to the power of 3x times 2 to the power of negative 3. Step 8. Now, since 2 to the x equals 10, 2 to the power of 3x equals 10 cubed. Step 9. Simplifying, we have 10 cubed divided by 2 cubed, which is the fraction 10 over 2, all cubed. Step 10. Therefore, our final answer is 5 cubed, or 125. We'll work through 2 interesting examples where we have a key piece of information, and we need to find the value of related expressions. Let's begin with our first example. The problem states, if 2 to the power of x equals 10, we need to find the value of 4 to the power of x plus 8 to the power of 2x. Let's start by recognizing what we know. We're given that 2 to the power of x equals 10. This is our key information that we'll use to find the value of the expression. Now let's look at what we need to find. 4 to the power of x plus 8 to the power of 2x. The key to solving this problem is to rewrite 4 and 8 in terms of powers of 2. We know that 4 equals 2 squared and 8 equals 2 cubed. Now we can use the power of a power rule, which states that a to the power of m, all raised to the power of n, equals a to the power of m times n. Applying this rule, we get 2 to the power of 2x plus 2 to the power of 6x. Now, let's rewrite our expression a bit differently. We can express 2 to the power of 2x as the square of 2 to the power of x. Similarly, 2 to the power of 6x is the sixth power of 2 to the power of x. But we know that 2 to the power of x equals 10, so we can substitute 10 for 2 to the power of x. This gives us 10 squared plus 10 to the power of 6. Let's compute this step by step. 10 squared is 100. 10 to the power of 6 is 1 million. So our expression equals 100 plus 1 million, which gives us 1,100,000, or 1,100,000. Now, let's move on to the second problem. Again, we're given that 2 to the power of x equals 10, but this time we need to find the value of the expression, 2 to the power of x minus 8, all raised to the power of x. Once again, we start with the information that 2 to the power of x equals 10. Let's directly substitute this into our expression. We get 10 minus 8, all raised to the power of x. Now, let's simplify inside the parentheses. 10 minus 8 equals 2. So our expression becomes 2 raised to the power of x. But remember, we know that 2 to the power of x equals 10. Therefore, our final answer is 10. Here's our problem. If 2 power a equals 3 and 3 power b equals 2, find the value of 2 power a plus b plus 3 power a plus b. Let's start by using the exponent properties to expand our expression. We can rewrite 2 power a plus b as 2 power a times 2 power b, and 3 power a plus b as 3 power a times 3 power b. Now we can substitute the values we know. From the given conditions, 2 power a equals 3, and 3 power b equals 2. We now have 3 times 2 power b plus 3 power a times 2. However, we don't know what 3 power or 2 power be equal to directly, but when we look at our given conditions, we can derive them. We can rearrange to make our expression clearer. So we have 3 times 2 power b plus 2 times 3 power a. Now, let's solve the second part of our problem. For our second problem, with the same conditions, we need to find the value of 2 power negative a plus b plus a times b. Let's start by rewriting 2 power negative a plus b using exponent properties. This is equal to 2 power negative a times 2 power b. 2 power negative a can be rewritten as 1 over 2 power a. So our expression becomes 1 over 2 power a times 2 power b plus a times b. From what we know, 2 power a equals 3. So 1 over 2 power a equals 1 over 3. Our expression now becomes 1 over 3 times 2 power b plus a times b. Our final expression is 1/3 times 2 power b plus a times b. Let's look at our example. If 2 to the power of x equals 3, then find the value of the expression, open parenthesis, 2 to the power of 2x minus 1 minus 2 to the power of x minus 1 minus 2 to the power of 0, close parenthesis, raised to the exponent 5x minus 5. Let's begin solving this problem. Since we're given that 2 to the power of x equals 3, we'll substitute this information into the expression. In step 2, let's apply the exponent properties. We can write 2 to the power of 2x as 2 to the power of x squared. Similarly, we can write 2 to the power of minus 1 as 1/2. This gives us 3 squared times 1/2 minus 3 times 1/2 minus 1. In step 3, let's simplify the expression inside the parentheses. We have 9 times 1/2 minus 3 times 1/2 minus 1. Simplifying this, we get 9 over 2 minus 3 over 2 minus 1. In step 4, let's further simplify the expression inside the parentheses. We have 9 over 2 minus 3 over 2, which equals 6 over 2 or 3. Then we subtract 1, giving us 3 minus 1, which equals 2. In step 5, we need to simplify the exponent 5x minus 5. Given that 2 to the power of x equals 3, we can determine that x equals log base 2 of 3. Since 5x minus 5 equals 5 times x minus 5, let's find the value of this expression. In step 6, we can substitute the value for x into the exponent. Given that 2 to the power of x equals 3, we know that x equals log base 2 of 3. So, substituting this into 5x minus 5, we get 5 times log base 2 of 3 minus 5. In step 7, we can apply logarithm properties. Using the property that a to the power of log base of b equals b, we can simplify 5 log base 2 of 3 as log base 2 of 3 to the power of 5. In step 8, we can use another logarithm property. 2 to the power of log base 2 of 3 to the 5th power equals 3 to the 5th power. So our expression becomes 3 to the 5th power times 2 to the power of negative 5. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.